Hello my dear students and welcome back to our chemistry video series. In this session we will solve question 2, paper 42, February March 24. Let's start. The elements in group 7 of the periodic table are known as the halogens. Halogens can form halide ions. Letter A identifies a halogen with the lowest density at RTP. RTP means room temperature and pressure. Look at group 7. This is part of periodic table, group 7 here. Okay, start with fluorine and ends with tennessine. What about physical state of these elements? Fluorine and chlorine are gases. Bromine is a liquid. Iodine, astatine, and tennessine are solids. As fluorine and chlorine are gases, they have the lower density than bromine. But look at fluorine. Fluorine with atomic mass equal 19, while for chlorine atom, the atomic mass 35.5. Which one has lower density? Fluorine. Okay, so the answer is fluorine. Letter B states the appearance of bromine at RTP. Bromine at school lab or chemistry lab, it has reddish brown color and it is a liquid. Letter C. Use the periodic table to give the symbol of the halogen with the highest atomic number. This part of the periodic table, group 7. Okay, as we move down the group, the atomic number increases. So, sure, tennessine with the highest atomic number with 117. The answer TS. Deduce the number of occupied electron shells in an atom of this element. The relationship between the number of electron shells in any atom is related to its location in the periodic table, in which row, in which period. So, look at this part of periodic table. Periods 1, 2, 3, 4, 5, 6, and 7. 7 periods. Okay, lie horizontally in rows. The first row contains 2 elements, hydrogen and helium. This is period 1, while for the last period, period number 7, start with francium and ends with OG. What about tennessine? Tennessine lies in the 7th period. So number of occupied electron shells equals 7. Okay, 7. So look at tennessine atom nucleus surrounded by 7 electron shells. By chance, the outermost shell also contains 7 electrons. This determines the group number, group 7 and period 7. Okay, this location of tennessine. Letter D. Bromine molecule have covalent bonding. State what is meant by the term covalent bond. Covalent bond means 2 electrons shared between 2 atoms. So pair of electrons. This pair of electrons shared between 2 atoms. These 2 electrons, okay, revolve around the nuclei of both atoms with the same speed at the same time. So fluorine F2, 2 atoms are shared. This called pair of electrons. Okay, here for chlorine the same. For bromine, each atom share with 1 electron. These 2 electrons revolve around the nucleus of bromine atom like the other atom, okay, with the same speed. Letter D. Bromine molecules have covalent bonding. State what is meant by the term covalent bond. Covalent bonds means 2 electrons, pair of electrons, shared and revolve around the nuclei of 2 atoms. So pair of electrons shared between 2 atoms, like for fluorine F2. Here each atom of fluorine share with 1 electron. Both electrons revolve at the same time with a high speed around the nuclei of both atoms. Okay, What about chlorine? Chlorine Cl2. two electrons share together to form pair of electrons revolve around nuclei of chlorine. The same for bromine. As we know, all elements of group 7 of halogens are found as diatomic molecules. We write each element in equation as diatomic. We write F2, Cl2, Br2, double I. Name one halide ion which bromine molecules can displace. Bromine lies below chlorine and above iodine. As we pass or move down the group, what about reactivity? Reactivity decreases. Okay, bromine can displace iodide ion, acetate ion, and tennesside ion. He asked about halide ion, not the element, the ion of the element. Iodide, acetate, and tennesside ions. But why? Explain why bromine can displace the halide ion in D double I. Look at the same figure. Bromine lie above I, AT, and TS. Okay, as it lies above each one of them, so it has higher activity, is more reactive than iodine, astatine, tennessine. Name a halide compound which can be used to detect the presence of water. We use a famous compound called cobalt 2 chloride, COCl2. Anhydrous cobalt 2 chloride, COCl2. As this anhydrous compound with blue color bind with water from atmosphere, what would happen? It form certain hydrated cobalt 2 chloride with reddish or pink in color. This simple COCl2.6H2O, this hydrated form. Look at this video or this animation. This paper of cobalt chloride, anhydrous cobalt chloride, this blue in color. When we add just one drop of water, it turns into pink or pale pink color. This indicates it turns into hydrated form of cobalt 2 chloride. What about when we heat this paper, gently heat this paper, it turns blue again. So it turns into blue by heating. This remove water of crystallization. Okay. Letter F. Calcium chloride is an ionic compound, CaCl2. Complete the dot and the cross diagram in figure 2.1 for the ions in calcium chloride. Give the charges on each of the ions. Here CaCl2, 1 calcium ion and 2 chloride ions. Look firstly at chlorine. Chlorine atom 287. So 1 orbit or 1 shell is missed. The last shell. Containing how many electrons? 7 electrons. Okay. The same for the other chlorine atom 287. 1 electron orbit or shell is missed, containing 7 electrons. Okay, with dots, black dots. Now for calcium 20, 2882. The outermost contains 2 electrons. Calcium is metal. During chemical reaction between calcium atoms and chlorine atoms, what would happen? Excitation of the outermost electrons, and calcium tends to lose these 2 electrons for both chlorine atoms. Look, how many shells are missed in this diagram? The third shell and the fourth shell. The third shell full with 8 electrons. The fourth shell contains 2 electrons. During excitation, the electrons lost. The last 2 electrons are lost. Okay, and gained by chlorine atoms. Look, when this 2 chlorine atoms gain electrons, it change into chloride ions containing 288. Cl minus. The same for the other chlorine atom. Okay, also gain 1 electron and changes or turns into 288 Cl minus. So we write -1 on square brackets, okay, above the square brackets. What about calcium atom? When it loses 2 electrons, what would happen? It turns into calcium ion, Ca plus 2, 288. Where is the fourth shell? It is missed 2, like the 2 electrons. No fourth shell found. So we have to erase this outermost shell. Please erase the calcium last shell and the outer 2 electrons. Letter G, aqueous lead 2 ions are added to aqueous chloride ions. A white precipitate of insoluble lead 2 chloride BbCl2 is formed. Single I, name a lead 2 compound, can be used in this reaction. We search for certain compound of lead which is soluble. So we use lead nitrate, lead 2 nitrate. Why? Because all nitrate salts without exception are soluble. When we add lead 2 nitrate into solution containing chloride ions as halide ion, what would happen? A white precipitate is formed due to formation of BbCl2, okay, like in this animation. The same, okay. Double I. Write the ionic equation for this reaction. Include state symbols. Here, look at this video about reaction between lead 2 nitrate and sodium chloride. For example, this bottle containing lead nitrate salt, we prepare solution of lead nitrate BbNO3 by 2. It's colorless solution. Also, soluble solution of NaCl. Look, when we add here lead 2 nitrate in test tube and we add just one drop, just few drops of sodium chloride, what would happen? Immediate white precipitate is formed. Okay, this is called double displacement reaction or precipitation reaction. NaCl solution by dropper or pipette, 1 drop. This insoluble precipitate, insoluble white precipitate of BbCl2. Okay, now look at the equation. BbNO3 by 2 equals form plus 2 NaCl reacts to give 2 NaNO3 plus BbCl2 as solid. Here the physical state is important. We have to mention the physical state of compounds. What is meant by aqueous compound? Aqueous compounds means ionized, completely ionized. What's meant by S? S means solid, I mean insoluble. So look at the same equation. We have to dissociate ions of lead 2 nitrate into Bp plus 2 plus 2NO3 minus 1. NaCl also dissociates into 2Na plus and 2Cl minus, 2 chloride ions. Okay, all reacts to give what? 2Na plus 2NO3 minus 1 plus BbCl2 immediate precipitate as solid, insoluble solid precipitate. Look at left hand side and right hand side. Okay, similar ions are found in both, like what? Like nitrate found in both. We can cancel this similar ions, also sodium in both sides. This is called spectator ions. What the remaining items or species present in this equation? Look, Bp plus 2 in aqueous form, okay, plus 2 Cl minus, 2 chloride ions, okay, combine together to form solid precipitate. What about the first 3 equations are not needed in the exam, but we have to study them. How to obtain the last formula or last equation as precipitation reaction or double displacement reaction of this question. Okay. Letter G, aqueous lead 2 ions are added to aqueous chloride ions. A white precipitate of insoluble lead 2 chloride PbCl2 is formed. Triple I, name one other insoluble chloride other than PbCl2. As the rule of chlorides, most chlorides are soluble except silver chloride, lead chloride, mercuric chloride. So we can use one of these compounds. So silver chloride is the answer. Okay, when we add solution of sodium chloride, table salt solution, to beaker containing silver nitrate, what would happen? Silver chloride precipitate, also white in color, is formed, AgCl. Thank you for watching. See you next time in next video. Bye bye.